Hello all. Everyone's doing well. Hold on, I have to sign back into the Google Drive. And we're back. Okay. Now, right. So tonight's lesson is on some of the suppliers in FRC, good mechanical design, and then we're going to do threads in Onshape. So there are a lot of suppliers in FRC. VEX Pro, AnyMark, So these up here are all FRC specific. They'll have things like our control system components, things like, motors that we're legally allowed to use, all that stuff. Oh, really go. And that, like, here's like the VEX Pro website. You can see they've got like motors, VersaFrame, which is a lot like the metal that we use. It's just got a whole pattern pre-drilled into it. We can kind of just make our own mostly. Electronics, various control system components. They've got some pneumatics mostly for their shifting transmissions. They've got, solenoids, fittings, other stuff. Also, I didn't confirm my mic is actually working. Which it is. Okay, good. Yeah. Mounting for shifters, and then these cylinders are tiny little ones that we use for shifting. You probably, if you're working on the robot gearbox last night, you probably recognize these, and that's where we buy them from. And the pneumatic control module. That's VEX Pro. AnyMark, another big one. They've got tons and tons of compliant wheels, but also like AnyMark makes the Kitbot drivetrain. They have a bunch of FTC stuff as well, which is FTC is the robotics competition level below FRC. Yeah. Oh, power servo connector. Huh. Oh, power Sauro connector. Green's actually quite a ways away from me. But they've got like bumper material. I mean, you name it, AnyMark probably has it. They may not have the best version of it, but they probably have a version of it. Like you could build your whole robot from AnyMark parts or parts purchased from AnyMark. Would it be the best robot ever? Maybe, maybe not. West Coast products, mostly what they make is they do have some like complete mechanisms that you can buy that are like if we want an elevator, we could just buy $1,000 elevator. Oh wait, no, $200 elevator or a $150 launcher. Huh, we got like tiny little Omni wheels, rollers and stuff. Like we could even just buy a turret from them to put our shooter on if we made some massive modifications to our upper structure. But what we normally, if we buy things from them, it's either a gearbox. You saw you saw some of these 2 days ago, and belts, chain, gears. We get a lot of stuff like that from them. West Coast Products works a lot with VEX, so these guys. So there's a lot of overlap, and sometimes it's who actually has stock, who can ship out the fastest, stuff like that. Dirtybots kind of a cool supplier. They try to keep things cheap, even though their Mecanum wheels that we bought were like $50 for four. Granted, like I couldn't get in, a factor of 10 cheaper building it myself, but it was like a factor of two. But yeah, they have like vectored intake wheels. You can buy. They mostly specialize in 3D printed stuff. Like you can actually, if we need something to be super ultra strong but also 3D printed, we can request them to print something for us. Um, I have some bearings that are actually pretty cheap for what they are. We probably need to look at our stock of those before next season. Um, they also have like a fully 3D printed swerve drive somewhere. Oh, yeah, $200 3D printed swerve module, dually swerve for some reason. Well, okay, I guess that's how you get. Michael's saying we need uh 6-wheel swerve. We can get him 8-wheel swerve if he's got the money to pay for it. Or Coach Zinovich, sorry, I keep that's something new we introduced for this year, so I may slip up and call my fellow mentors by their first names. It doesn't mean it's okay for you to. It's just something that it'll probably end up happening quite a bit. Um, but yeah, so now it doesn't include the motors obviously, but yeah, $200, and you'd need 4 of these for a drivetrain. Technically, you could get away with less, but that would just be silly. CTR Electronics, they're they have a new site. But they have Falcon 500s. See, they're $140. They've got sensors and our older control system stuff. A supplier that we'll get to in a minute is making new control system stuff for this year. So that's will be interesting to see if A, we can even afford the new stuff, B, how well it performs. But yeah, this is, electronics. They mostly have first electronics for us. Rev is also mostly electronics, but they have the Neo family motors, the Spark Max. You can see the new control system stuff. Here, oh wait, that's. Oh yeah, they have a 75 millimeter Mecanum wheel set for $110. That's 75 millimeter. That's like somewhere around 2 inches, I want to say. Yeah, that's expensive. Uh, Ultraplanetary gearboxes, which are just about they're what you really want to use if you're using a Neo 550. Yeah, they've got everyone has their own kind of compliant wheels, an endless debate about whose is better. It, but they do sell some fairly nice gussets and motor brackets, stuff like that. Yeah, extrusion exists. We rarely use it. It's really strong stuff, but it's overkill for 90% of what we're doing. And you can usually make something that's better and lighter out of just tube aluminum. Better as in stronger by just, putting tubes in the right places and making sure that loads are supported. Electronics, they've got, sensors, cables for the Spark Max. We can get we could put LEDs on the robot if we have weight for it, and ideally have a function for it. then, you know, non-FRC suppliers. McMaster car, if it exists and is engineering related, they probably have it. Like, I'm not going through this stuff. And they ship really fast. Like, the polyurethane belt was bought from here. Coach Bargeman bought it on Monday. They had it ready for him to pick up on Tuesday in a place that he didn't, that in like Virginia, because he accidentally ordered it for pickup in Virginia. He sent them an email and they had it shipped to his house by Wednesday. Yeah, McMaster Car is a company to keep in mind. McMaster Car is kind of pricey usually, but you know, sometimes you need it next day. You need something very specific where you need it next day, and that's where McMaster Car comes in. Automation Direct, they have a lot of sensors, and a lot of what we buy from them is pneumatic stuff. So, you know, they exist. Amazon, it's Amazon. They have, if it exists, it's probably for sale on Amazon. Maybe not the cheapest price again, but you know, if we need it fast, etc. SMC makes more pneumatic stuff mostly. I mean, I think they also have various sensors and, you know, yeah. A lot of stuff that looks like it would be very illegal on our robot, but the, you know, pneumatic stuff is legal. Bimba makes pneumatic cylinders and among other things. Manifolds, like yeah, pneumatics. You end up pricing them. Nitra, I think that's Automation Direct's cylinder line is Nitra. You usually end up, you know, cross comparing Automation Direct and Bimba and SMC for air stuff. And air hydropower, I hadn't heard of them before, but I actually found them while making this slideshow. They make a lot of pneumatic stuff that we could probably use, so we'll have to see if they um, have competitive prices. And Digikey, you know, if it's an electronic thing, it's probably on Digikey in some form or another. And you know, that's not an exhaustive list, but you know, it's just places to try when you're trying to find a part. And there's this thread on Chief Delphi. I'm gonna move this over to my main screen so I can see it a little better. There's a thread on Chief Delphi. You know, you guys have access to the slide deck and you can see all this, but like teams suggesting things that you should have around, or you know, you need different parts. Like here's a bunch of McMaster part numbers for like a really good high temp Velcro, miter gears for versaplanetaries, miniature air gauge. I need to remind Coach Bargeman, we need to actually get some of these miniature air gauges because we're out of air gauges and we need to buy more before next year. And y'all haven't heard, logistics in the coming months are going to be difficult to deal with. So we may want to buy some of the stuff that we think we'll need. But, well, especially if we know we're going to need it, we better buy it now and hope it gets here by the time the season starts. And if we might need it, then we may need to do some fundraising to make sure we can secure stock of some of these items. Some of these items that they put in this thread are absolute memes. Like I don't think we need a stop sign. And even if we did, I'm not paying 73.48 for a stop sign when I'm sure like Do It Best or something has something equivalent for like $20. Huh, coffee. McMaster car sells coffee makers. Refrigerated. Huh. Well, you learn something every day. Big crumper. We actually might need one of those. Huh. Used 26 bucks. We might think about that. But anyway, so, a lot of times we end up doing things the hard way, and if we got the right tool or the right part, it would be a lot faster. And we always try to, find pioneering ways to save money, but then we look at the amount of time we spent on it, and it's like, man, we should have just spent the money on the actual real part. All right. So, and he is complete guide to FRC. We're changing gears into design. Good, like the whole thing's a good read. I'm gonna borrow a part of it for the current presentation because I looked at it and it said everything I was going to say anyway. So rather than reinvent the wheel, I'll just present this other PowerPoint and maybe just add my insights to it. So we're going to look at the design part. So if I can find that mechanical and over. See, everyone can read this. I'm not going to read this out loud. You all can read. I'll make a note of the time and make sure we spend about at least 2 or 3 minutes here. But, the short form of this is that, um, you know, CAD. We're doing CAD lessons, but you should always be ready to just try stuff and Google how to do stuff if you don't know what you're doing. Because, like, I don't even know all the things that, Onshape can do. Like, I really don't. And, we don't know how to do it. It's probably a Google search away. And, you need help Googling it or help trying to find what you're doing or find the words, ask a mentor. And, also the concept of a design review. If you guys saw yesterday, we're going to have that like parts tracking list. We're not going to be in the shop every day. We're probably going to have at least a couple off days per week. And they're off days in the sense that you don't have to come into the shop, but I would expect that if we are actively trying to, win competitions and go to worlds, and then potentially win worlds if we're, really awesome, there should be work getting done, on CAD remotely. There should be work on programming even getting done remotely while we're not in the shop. And, because it used to be before, say, the 2019 season, we'd spend like every day in the shop putting in crazy hours. And a certain amount of that work we just don't need to be in the shop to do. We especially anymore with Onshape, with GitHub, we can do a certain amount of work remotely. And not only that, just getting people out of the shop while they're working, it might give you different inspirations and ideas on things to do, rather than just seeing the shop all the time, you know. Sit on your back porch, take some inspiration from nature. Sit around your house, take some inspiration from random appliances around. I mean, you'll find that a lot of the intakes we build have a very similar design ethos to like the rollers on a vacuum trying to pick up dirt. It's just we're picking up a game piece instead of dirt or, for those of you in ag, combines are very similar to our robots that we build in design ethos and etc. It's just we're building a miniature Formula One combine as opposed to, you know, a big, heavy, reliable industrial thing. Our robot still has to be reliable. It just only has to be reliable for, 2 minute and 30-second periods of time, not hour after hour after hour out in the field. Um, and yeah, you want to build for a strategy, etc. Basic physics. Um, Physics are a good way to see if you can figure out like how much force is required to do something, and then usually, it. Let me back up. Figuring out the amount of force that's required to do something, or how much power it's required to do something in a certain amount of time. So like your basic, just basic physics equations and like work calculations are just good to, sanity check whether or not an idea is even feasible. We used to have a physics teacher, mentor on the team, and it was helpful for sure. But, you know, it, like we were talking in the all team meeting about, torques and their velocity and acceleration, you know, those are all fairly important things um, to be able to just calculate and see. And even if you're ballparking whether or not it can be done, it's good to do because sometimes you come up and it's like, huh, this mechanism will be off in the amount of power it has available to it to accomplish the goal by like a power of 10, and that's not even taking into account efficiency losses. Maybe this idea is infeasible and we should abandon it. But yeah, basic physics, sum of forces and torques. Up and solve these problems. There's a website. I'm not going to go there today because, etc. Oh yeah, we measure a lot of our velocities in feet per second. Um, Angular velocity is usually in revolutions per minute, and mass is measured in grams or kilograms. Okay, mass is measured in grams or kilograms for the purposes of physics equations, but remember the rules give us a 125-pound limit. By the way, we need to remember to weigh the robot sometime before Cowtown to make sure we're still compliant. Acceleration is change in velocity. Yeah. Newton's three laws. Object in motion, inertia, force equals mass times acceleration. Every reaction has an equinox reaction. The rest of this you guys can go over, either take, is either just physical science class all over again, or since I guess you all are sophomores, or, you know, stuff that we can Google or, you can ask, hey, is there a way we can model this with physics? And I may not know off the top of my head. I passed my college physics class because all the tests were open book. And I actually got a pretty good grade in that, but there were people struggling even though it was open book. I'm not saying I remember all this, but if I go find the equations, I can figure out how to solve it. And so yeah. Um, so materials and making. I'm going to sum this up as you need to learn what our shop is capable of making before you kind of start designing. So I'll kind of just go over that really quick since I don't have a slide for that. So we have a plasma CNC, which is good at making like flat plates with intricate designs, but not necessarily precise designs. So, like, the triangle, circle, square on our drive rails was cut out by the plasma cam. However, we needed to use the mill in order to get the bearing holes for the drive shafts to come through. So, yeah, CNC plasma is for intricate but not precise. CNC mill is for precise but not intricate, like holes, surfacing, etc. Oh wait, it's not a CNC mill. If I said it's a CNC mill, I lied. It is a manual mill, but it is very precise. We can get very precise holes with it, very precisely sized things, and make a gearbox line up if we really have to. The lathe is for making shafts and stuff. We have a 3D printer, which is for not necessarily precise, but like oddly shaped, but um, kind of precise or oddly sized things like our rollers. They don't make a 2.69-inch roller with a crown and not crowned. So I 3D printed those to get them, exactly right for our existing machine for that adaptation. 3D printer is also used to save money on pulleys because we can 3D print pulleys that work reasonably well. And we have some basic stuff like drill press, etc. So most of what we do is, box tube aluminum. Oh, and we have a CNC laser for making intricate and precise polycarbonate pieces or plastic pieces or wood pieces for prototyping. So, just kind of knowing what our, the tools we have access to are reflected in our robot design language, where it's mostly box tube, aluminum, and then, either, you know, milled holes with plasma cut, light weight reduction for fun, and, like our intake that has like precise stuff that needs to be flexible is, precision cut polycarbonate. I doubt that King Tech still only uses bandsaw drill press. They're pretty good. They made the tool that one of their alumni made the tool that we're buying to um put those belts together for the conveyor system. Drill press. We have a few of these, I think. Yeah. Um, Michael or Coach Zinovich will probably go over all this stuff for you when you use the drill press. One thing I want to highlight here is well, is you can print out CAD drawings one to one, like in actual size, and then tape it to your workpiece so that you get the hole sizes and locations right. Bandsaw. I'll put sideways force on the blade. When cutting. Yeah, I'll let you read that really quick because I'm not the big mechanical guy. Like I can do stuff, but I don't. My work tends to be on mechanical things tends to be sloppy and just try to get it done fast because I like to get back to programming. So, you know, I leave it to the people who are actually take pride in that stuff and go slow and do things right. Don't have to worry about the price. We have multiple band saws around. But yeah. But yeah, so yeah, you can trace out, or what I would do is I would again print this out. You can even like print multiple pieces out and like have keys on them to where you can like line them up and then tape them down and then bandsawed off that way. Miter saw is a different kind of saw, but you can lock in an angle. So if you need like corner cuts, if we were going to do like a corner cut on our drive frame, we have this. Let me see if there's something better here. We actually have something better that's not covered here. We have a hydraulic automatic angle cutting saw out in the shop next to our CNC plasma. And boy, is that thing nice, and it makes really good cuts on aluminum if you use it right. Milling machine. We have that giant Bridgeport. Yeah, corners will always be radius to your mill bit or your end mill or whatever tool you're using. Sharing. So that's what the mill is used for. It's a it's a 2.5 axis machine for when you're just barely trained. You get really good at that mill. I mean, you can do 3-axis stuff, but and again, if you don't know how to make it, you shouldn't design it. You should design something where you can understand how, all right, I'm going to put the hole in this spot with this machine, etc. CNC milling. We wish we had one. We can maybe ask sponsors or find sponsors to CNC apart if we really need to. We may really need to for our custom gearboxes. That may be something we have to seek out anyway. Anyone knows anyone with a CNC milling machine that might be willing to let us borrow it, or might be willing to make parts for us because we can outsource it to them, let us know because we could use it. CNC router, again, we wish we had one. It's they're effectively lightweight 3-axis CNC mills. Omeo CNCs are really popular in FRC. Oh, $1,100 CNC router. I may have to go look that up after this presentation and see if we can afford that. Water jets. So a water jet is like our CNC plasma, but it uses water with abrasives in it, and it can cut way more precisely than our plasma. So if we had a water jet, we could like just about take 90% of what we do on the mill and just do in the water jet. Or if we had access to a water jet that, a sponsor was graciously willing to let us use, we would do that and spend less time on the mill. Lathes usually used to, do operations on shafts, drive shafts, X shafts. Where to buy things, we kind of just went over that. 80/20 aluminum is this extrusion. You saw something similar on the Rev site. I would say it would be great stuff for like mocking things up, but it's kind of expensive. So we'll probably just use prototype, which will hopefully get you some hand-on experience with before the kickoff season. Probably after Cowtown, but before kickoff. Yeah, by Versa Chassis Tube. Does that stuff on VEX's website. Or we could just go buy, our normal 2x1 and drill some holes in it for what we need. Or, 80/20 is pretty heavy for use on an FRC robot. Tapping. Tapping is the process of putting threads on a hole. Yeah, I'd recommend reading this. if you can. Oh yeah, aluminum threads are kind of weak, and you don't want an aluminum threaded part that you take in and out all the time. It's really easy to break a tap, which is the tool used to tap the holes. So, be very careful with these. I don't know that they're extremely expensive, but I think they're annoyingly expensive compared to how easy they are to break. Materials. So, I say we use aluminum a lot. Like, I'd say a good 70% of the time, the aluminum that we're using is good old 6061 alloy structural aluminum. It just so happens that the various different kinds of hex shafts that we have access to are different alloys. Like Rev has a hex shaft that is like 5051, which is weaker than 6061, but it's easier to weld. So if we, ever needed a like welded shaft, we might go with that. VEX Pro hex shaft is it's some 7000 series. I think it's 7001 or I'm gonna look it up right now. Rather than tell you the wrong 7075 T6. Oh wait, they do 6061 T6. Huh. Half inch. Oh, is for the two. So yeah, those hex shafts that we use are 7075 T6. You cannot weld this stuff. I don't know. Coach Zinovich may argue with me, but you cannot weld 7075 aluminum well. It is difficult. Welding aluminum in general is difficult enough because you have to TIG weld instead of MIG weld, which is, again, I'm not the um, fabrication guy, but from what I understand, TIG is just a much harder process than MIG. But yeah, and then 7075 is hard and brittle. So 7075 is also known as like aircraft grade. So it's really, really strong, but probably more likely to snap a shaft than twist a shaft, I would think. I mean, well, and 5052 is soft, so if we use, Rev, that's 5 mil. Hold on. RC structure, maybe in motion. Ultra X shaft. It is, 6063. That's okay, so it wasn't a 5000, it was 6063, which, what are the properties of that? Magnesium and silicon. Oh, it's high melting temperature. Connectivity, high heat capacity. 6063 has a better surface than AL6061 and is preferable for architecture. So it looks nicer than 6061 and it's more heat resistant, which if it's a drive shaft, that's probably a good idea. But yeah, still, 6063 like 6061 is weldable. So if we ever, for some reason, need to weld in a drive shaft, this is what we want. If we ever want to like have a stationary pulley for something like an intake that needs to like rotate out on the end or something, I'd have to draw what I'm thinking of. But if we ever need a stationary piece of this, we may look into this as opposed to the VEX stuff. The VEX stuff is stronger, but you can't weld it. Um, Plastics, we use polycarbonate a lot. Can bend it with a heat gun. We actually have a bending brake out in the shop too, so we can do, bent angle pieces. HDPE is, we probably need to leverage HDPE more because polycarbonate's actually fairly expensive, maybe even overkill for a lot of what we do. We could very easily machine and work with HDPE. It is a bit dense, so it might be a weight issue. But for certain things, maybe it's not worth getting polycarbonate for it. The one that's not listed here is acetal or Delrin, are two names for it. It's actually what those shaft spacers are made out of. According to Team Spectrum, that stuff cuts on our laser, like should cut on it really nicely and really easy. So for certain parts, we should use that maybe more often. The cross-sectional area. So yeah, a thicker piece of metal is stronger than a thinner piece of metal. You know, thicker piece of plastic is stronger than a thinner piece of plastic. Other thing is you can when we have that bending brake out in the shop, out in V-Rock shop. Putting bends in like sheet metal designs and makes them stronger. That's part of the reason that our tube is so strong is because it inherently has 4 bends in it. So it's stable in a lot of directions. Stuff like that. And if you want to do this, if you have access to a sheet of paper, you can do this activity, or you can take their word for it, or even if you've done that before, bother. Um, we always, yeah. So when you're doing sheet metal, you want it to be strong. Throw a bend in it somewhere, even if it's just like along the edge, to have a bend somewhere in it. And you can see a tube frame fairly similar to the designs we make. That's 2117's 2014 robot. I actually use some polycarbonate because polycarbonate flexes better and returns. Because the Thintate in that game was absolutely completely violent, and aluminum would eventually just bend, and you'd have a hard time getting it back. Um, Polycarbonate, it may eventually bend, but getting it back is fairly easy. Filleting. The short version of this is corners focus forces on them. So there's a fillet option in Onshape that you should use whenever it makes sense, because it'll spread the load out along this entire area rather than giving it a single point to focus on. Because if you don't, that's under any appreciable load, it will crack. It's how a lot of our welds crack, is because we don't, fillet our drivetrain, which that's just because filleting a drivetrain is really difficult. Cantilevering. We do it on our drivetrain because it's in tube. Um, is Yeah, on rotating shafts, like if it's reasonably possible, you should support both ends of a shaft. Otherwise, it goes all weeble wobbly, and you break things. And breaking things at competition is not fun. I mean, you'll learn from it, but you know, enough things will break on their own without us actively doing making bad decisions that leads to things breaking more than they should. Our West Coast Drive is fine being cantilevered because A, it actually makes maintenance easier, but B, it's in a tube, so it's got multiple support points. Um, yeah, there's a sum of torques problem. So you can actually actually don't know how to do that math, but there is a way to figure out if you can get away with cantilevering something. But it's a pain in the butt, and it's probably easier just to not cantilever it. Lightweighting. It showed you the the lightning tool in Onshape. You know, use a diagonal, use triangles, think about the directions the forces are coming from and the ways it's going to try to compress and stretch. You want ideally a straight line to in every direction. Yeah, and you can see all the round holes, and they're removing weight in directions that they don't expect to see much load. So it's really strong side to side, but lightweight up and down. Press fits. Yeah, we have a press that we can use to press fit things. That's something Coach Pazinovich will go over when we need to do it. Oh yeah, rivets. This is actually a pretty good diagram of how a rivet works. Um, you do have to use a lot of rivets to get the same like holding force as like a bolt or a weld. But the maintenance on them is fairly easy, and you can only bind together thin plates with rivets. Bolts, yeah, their team uses quarter 20. We use quarter 20 a lot. Number 6 bolts. I think, yeah, we've got some 632 stuff. 6 being the size numbering that I don't remember. I think that's like a gauge or something. I don't know. And 32 is the thread count. Oh yeah, bolts vibrate loose. Use Loctite Blue on everything that you can, or an eye lock nut. However, one thing that they don't say here that they really should: polycarbonate does not like Loctite. It Loctite will eat polycarbonate. Do not put Loctite on a polycarbonate part. Use an eye lock. Oh, and they say nylock nuts are one use. We sometimes reuse them, but it probably is best practice not to. Washers are, little discs that you put between the fastener head and the actual thing that you're putting on. Friction created by the bolts clamping. Bolts always need to be tight. Again, make sure everything's tight. Welding. Oh yeah, so welding, and this applies to our metal welding and is also our welding of our belts. The weld itself is very strong, but the area around the weld, because of the heat of the welding process, weakens. So it's not. It does slightly weaken the metal there. Oh yeah, and we can't weld steel to aluminum or any dissimilar metals. You know, use shaft collars to keep things in place. Use bearings whenever it's passing through a hole. The shaft it is. And the motor sections we went over. Yeah, the rest of this we went over. I made my own presentation on because everything in that is out of date. So, yeah, this will go to. So, threading an Onshape, there are ways to do it without a feature script, but I've done it. It's a pain in the butt. Let's not waste our time with that, because every other CAD software I've ever dealt with, which I guess is just Inventor, has a built-in threading tool. I'm just gonna go here, sign into Onshape. Go back to the feature script. That's well. Rollers. What I'm going to do is I'm going to I remember how to branch. So if you can't find a feature script to do something, well, you see. Oh, it's free. Okay, so yeah, that added to my toolbar. Here. I just make a sketch somewhere out in here. I'm going to use the point tool to make it point. There. I need center of that. And I go to creator. Okay, so I have to make the hole first. Yes, I am figuring this out live. Go back to my sketch. I'm gonna go find a quarter 20 hole size. OD 0.25. Quarter inch. Just, get your point there. Mention it to 0.25. Extrude. You do remove to cut the hole. You got a hole there. Then if we wanted to thread into that, use thread creator, got surface. Then 20 size. Yeah. This is quarter 20 ANSI standard. Unified. Yeah, I guess. Yeah, I guess. Okay, quarter 20 is an ANSI standard, so fully threaded. First starts one. Even left hand thread. Pitch. Thread pitch TPI 1.2. I don't need it in millimeters. Oh wait, threads per inch would just be 1/20. There you go. And that should give you a quarter 20 hole threaded. So that's, there's barely any thread there because this is a belly pan. But so you still have to go like look up like what the right threading is for the hole you want. But and to be fair, that's mostly just for the CAD. Like if you need to thread something, or you need to do like a custom thread for something. But yeah, I just remember like the pitch that's in TPI, but they were asking for inches per thread, so I had to take the reciprocal. I guess are there? I think that's. Yeah, I think that's it. So, um, yeah, I'm gonna ask, what machine would you use for weight reduction holes in aluminum? Also, if there's any questions, feel free to ask. Hopefully, hopefully my chat window isn't just delayed. Okay, it isn't. Anyone have an answer for? You are right. Catting the threads is not crazy important because we'll always have to create the threads after the part is made. Yeah, it's good to learn, and also sometimes when you make 3D printed stuff, you end up using like a weird custom thread to get things to work together because, a lot of, standard threads are designed for, you know, metal, not 3D printed plastic. Yep, that's correct, Coach Bargeron. But why didn't the students answer that? And also, why don't the students have questions? I threw a lot of information there. Um, What is a website that you would go to buy a gearbox for First Robotics, namely a sim, or a sim, a Neo, or a Falcon 500? Yes, first for the question. What what supplier would you use to get a um, Falcon 500 Neo or Sim gearbox? I mean, there's a lot of correct answers there. Bueller, Bueller. Uh, uh, okay, you forgot. That's Thank you for admitting that. Well, I will show you the what certain suppliers where you would get a gearbox. So my personal favorite place to get a gearbox for a Sim or a Falcon 500 or a Neo would be West Coast Products because they have very lightweight gearboxes. Oh, they also have a swerve drive. Huh. They have flip gearboxes, dual speed, 3 sim per side, 3 sim per side, or, Neo or whatever motor. 3 motor per side single gear. They got this actually really. Oh, that's for. No, that's Falcon 500s. That's a really lightweight little thing. And no, it's not free. It's, really not expensive. We, we really need to use that drivetrain simulator and see if having a low gear is actually worth it with only 2 motors per side. So West Coast products would probably be my personal favorite. VEX Pro probably has all the same gearboxes. Be fair. Um, it, yeah, they have all the same stuff. Maybe even a few more. Yeah, they have a few more options even. Another one would be Andy Mark. And like gearbox. The Tough Box technically works. Tough Box Classic technically works, but I doubt we would end up buying these because we just probably have a bunch out in a locker somewhere. Actually, we probably have a bunch of Tough Box minis out in the locker somewhere. So, oh, and I guess they also have some lighter weight 2-speed gearboxes, but they're not anodized black. Yeah, those would be some options. Yeah, I don't think Dirtybot has a gearbox yet. CTR only the electronics, and Rev, their gearbox is, you know, is mostly their gearbox that they have is for the Neo 550. Yeah. But yeah, like if you guys are stumped on some of these questions, after a minute, just say I forgot because, I'm doing this for you guys to learn. I'm not doing this just to say things for an hour and then log off. So, if you're not getting the information, you need to speak up, please. Because and and some of this information you just need to remember, where I link to it in here and that, we have a PowerPoint somewhere that links to the solution to this problem so that when you come up on it, you can at least go look it up because that will save time. Um, see. Also, here's one that we kind of very briefly went over, but I want to see if anyone picked up on it. What is the name for the kind of drivetrain we have? I'll give you all another 20 seconds to answer. Okay. So the robot that we're going to be using at Cowtown that we've been working on for, past few weeks and, with this group and for the last like almost 2 years now is yep, he's got it. West Coast Drive. What that means is there is one axle that is direct driven from one side's drivetrain gearbox, and then the rest are either chain or belt driven with the chain inside the tube, not or not inside the tube, but from the not on the towards the outside of the robot. Probably better if I had like a picture of it, but um, and with the wheels cantilevered. Yeah, that's actually a really good picture of it. Yeah, that's direct driven, and then there's either chain or belt running to these outer ones, and it's a skid steer drive. That's good to know because people at Cowtown will be asking you what kind of drivetrain you have. Because there's another element to these competitions that we'll go over. Uh, we will go over it next week. Yeah. So that'll be our Tuesday lesson next week is scouting. So, um, hold on here for another minute or so if anyone's got any questions. Um, and thanks for being here. Thanks for paying attention. And if any programmers on, I'll see you Saturday and next Twitch meeting. The rest of you, be back online Tuesday. right, that's a wrap.